Alkaloids. The word alkaloid, that oid means like. A humanoid is like a human, but is not human. An alkaloid is like a base. Alkaline is basic. So alkaloids are nitrogen-containing compounds, organic compounds, that are extracted from plant material. And many of these have been known for eons, basically, since anyone first thought to chew on a leaf. You know, they're like, hey, when I chew on that leaf, I feel really good. Or when I chew on this leaf, my big toe doesn't hurt anymore. And you wonder, how many people died, or got really, really sick just chewing on leaves? Anyway, it's amazing that the human race has survived. There are over 5,000 physiologically active alkaloid compounds that are known. We're just going to talk about a couple of them. Well-known alkaloids include nicotine. Nicotine is a nitrogen-containing compound, and it comes from plant material. It comes from the tobacco plant. Caffeine, we looked at these structures very briefly. I think your book also has a nice little inset talking more about these, and I would encourage you to read those just for your general information, but I'm not going to test you on those. Caffeine comes from coffee beans and tea leaves, and cocaine is another alkaloid, and that comes from the coca plant. Quinine comes, your book says what it comes from. It comes from a plant. This is quinine. Quinine is used to treat malaria. Atropine is another alkaloid, and this is used to relax muscles, oftentimes before surgery. So here we have highlighted the nitrogen. So these are heterocyclic amines. This one has 2, and this one just has this one. These are really funky looking things, aren't they? They're hard to draw. They're hard to look at. This one's a little easier to look at. We've got this nitrogen and 1, 2, 3, 4, 5 carbons. So this is a 6-membered ring. But then this nitrogen is bonded through 2 carbons to the carbon on the other side. So it's kind of like we've got this loop and then we've got a handle over the top. So they're really kind of complicated ring structures. Morphine, codeine, and heroin. This is an important family of alkaloids, the narcotic painkillers. And these are derived from the resin of the oriental poppy plant. So these are derived from opium. Opium is, of course, an addictive, I guess you would call it recreational drug. So morphine, here's the structure of morphine. Morphine is one of the most effective painkillers, but it's also very addictive. And so that makes it dangerous to be using. If you modify the morphine slightly, so what we've done here is we've taken this alcohol functional group here and made it into an ester. Everything else about these molecules is the same. You get codeine. Codeine is also a great painkiller, although it's not as effective as morphine, but it's less addictive, and so that's good. And then here's heroin. Heroin has these 2 ester groups on it compared to morphine. Heroin is even more potent than morphine is, but it's so addictive that there's no accepted medical use for it. They just feel like there is absolutely no good reason to take heroin. If you've got severe pain, morphine will take care of it. You don't need to get into the heroin stuff. Other derivatives of morphine include hydrocodone and oxycodone. And again, we just get very small changes here. These are often administered in combination with a second pain-killing agent, such as acetaminophen. And it's interesting, the book mentioned that one of the reasons for putting acetaminophen in there is because if you take too much of the combination drug, that has the acetaminophen in it, the acetaminophen will hurt you. And so it's harder to abuse the drugs that have acetaminophen in them. So that's considered to be a good thing. But, you know, lots of people do get addicted to prescription painkillers. And it's something that, you know, if you need a prescription painkiller, definitely use it. But just be on the lookout, because getting over something like that is not a picnic, and you can't go on doing that forever.